finish up this set of notes, and I'm going to try sitting down because I'm comfy. All right. So we talked about probability, right? We talked about how it's a spectrum, and as we go from 0 to 100, we don't have to have like 50-50 probability or 0% or 100%. But it can actually be anything in between, like 21% or 58%, something like that. Okay, we talked about probability distributions, which were these things, these charts that gave everything that we were interested in. So everything that can happen up top, and that was the X variable. And then we had the probability on the bottom. So each of the probability, or the probability of each outcome, are underneath each outcome as it's listed. Okay. Then we talked about how to combine these probabilities together. So if I was interested in the probability of like two things happening, I could combine them together using these probability rules. And the concept of these rules really depended on if we had things that were mutually exclusive or not mutually exclusive. Now, is there anyone who can remind me what mutually exclusive means? Okay. Yeah, right. If two things are mutually exclusive, they can't happen at the same time. Kind of like being even and being odd, right? You can't have something being even and odd at the same time. That would be an example of mutually exclusive. Okay. Now, since we had these three rules, two of them depended on not mutually exclusive or mutually exclusive. So when we had mutually exclusive events, we would just add together the probability. So it wasn't that hard. When we didn't have mutually exclusive, we would add them together and then subtract off wherever they intersected or where they both could happen at the same time. Okay. We also had a third rule that we called the complement rule, and that dealt with when we had opposites, right? So if AC or A complement was the opposite of A, if I wanted to find the probability of AC, I would just subtract 1 minus the probability of the opposite thing happening. Okay. So three different rules that we had to know. Let's see how we can apply them in a different way other than just a chart, because we talked about probability histograms, right? Okay. So we can represent discrete, which just means we can use describe them using whole numbers instead of fractions. Probability histograms. Let's say I had a probability distribution that looked like this. Okay, and we have all the events that can happen, so all the possible events under X, and P of X was the probability of 0, 1, 2, 3, 4, and so on. Okay, we can turn this into a histogram by putting all of the possible events on the X-axis, and the heights of the bars represents the probability of each of the outcomes that happen. Okay, so for example, the probability of 2 is the height of this histogram, which is 0.312. Okay. Let's see how we can actually answer questions using our probability histogram. Okay, so here we have a probability histogram, and it describes the number of children a person has. Now, I do want to modify this question a little bit, and I'm going to change this into exactly the number of children a person has. So if a person has exactly 0 children, or exactly 1, or exactly 2. Okay. Before we even go into this, is the exact number of children a person has, is that mutually exclusive or not mutually exclusive? What do you guys think? I think I hear a yes. Does anyone want to explain why we think it's mutually exclusive? Yeah, you can't have exactly 2 children and exactly 3 children at the same time. That wouldn't make sense, right? So this is definitely mutually exclusive, since we can't have 2 and 3 children at the same time. And that means that we're either going to use rule 2 or rule 3, right? So that's actually the easier rule of 2. Okay. So here we have a probability histogram. We have the heights of the histogram showing us the probabilities of exactly 1, 2, 3, 4, 5 children, and so on. Okay, let's try problem A. This one's pretty easy. What's the probability that a randomly chosen person has exactly 2 children? Jules? Good, right? You went up to 2 and you were like, okay, the height of that bar is 0.244. So that one was pretty easy. Okay. All right, next we want to find the probability that a randomly chosen person has fewer than 2 children. Okay. What's another way to say fewer than 2? Less than, right? Because there's no like bar for fewer children, but I can write this as x less than 2. Okay. Now looking at my histogram, what exactly am I going to look for less than 2? Like which numbers am I going to look at? 0 and 1, right? So less than 2 is the same as saying the probability that x is 0 or 1. Now remember, we're using mutually exclusive events, which means that they can't happen at the same time, meaning we're using rule number 2. How am I going to find this probability? Add them, right? So rule number 2 says you're going to find the probabilities and you're going to add them together. For p of 0, probability that x equals 0 plus the probability that x equals 1. Probability that x equals 0 is 0.273, right? The probability that x equals 1 is 0.160. And when I add these together, I'm getting 0.433. Okay. Any questions on part B? All right, how about this? Part C is very similar to part B. Try part C, and if you're done that, you can give part D a try, and I will be around to see if you're on the right track. But first, let's go over part C. I'm gonna get back in my comfy chair. That's nice. Okay. All right, part C, instead of asking for fewer than 2, this one's asking us if we have either 4 or 5. Oh, you did 3 or 4. Oh. Oh, okay. I thought for a second I was like, oh, you're okay. Yeah. That's okay. That sounds like something I would do. All right. So this one has 4 or 5. Ellie, do you want to take us through this one?
Yeah. So on 4 or 5, it just says the number of what it is. And since it's basically asking the same thing as B, it's just B, so I just added those two.
Perfect. So very similar to what we did in part B. We're using rule 2 since we're mutually exclusive, and we got 0.121. Any questions on part C? All right, now I saw some good answers for part D, but let's go over this one real quick. We want to find the probability of anything except exactly 3, okay? Now, the word except is in here. What is that a hint that we should, or what does that hint that we should do? Claire?
Complement rule.
The complement rule or rule 3, right? So whenever we see the word not, except, the opposite, something like that, this is a hint that we have to use rule number 3, which is the complement rule. And that says, if I have an event, AC, and I want to find its probability, and I know the probability of its opposite, or A, I can just do 1 minus that probability, okay? So I want to find the probability of not having 3 children, right? Probability of not 3. To find that, I can subtract it from the probability of 3, right? It's opposite. So having exactly 3 children is the opposite of not having exactly 3 children. What's the probability of having exactly 3 children? Using my chart. I think I heard it 0.154, right? So all I'm going to do is take 0.154, subtract it from 1, and I'm going to get 0.846. Okay. Okay, so Jules said, okay, my different way of getting the answer was Jules took the probability of 0, right? The probability of 1, probability of 2, not the probability of 3, right? Because we don't want 3, but the probability of 4, probability of 5, probability of 6, probability of 7, and the probability of 8, right? Okay, and what did you do to these probabilities? Yeah, right. You can add all of these up, right? So let me add all of them together. So basically you took all the numbers on top of here, except for 3, and you added them together. And did you get the same answer, Jules?
Yeah.
Yep. So there's actually 2 different ways to solve this. You can either use the complement rule, or you can add together everything but 3. Okay. Now, in my opinion, I think the complement rule is a little bit easier just because you don't have to do all that typing in your calculator. But if you feel more comfortable doing the right-hand side, that's good with me too. All right. Any questions on probability histograms? All right. Then if we're comfortable with this, we have a new set of guided notes to go through, something that you'll probably see on your homework. So let's start this and then we'll get into our quiz review. So we talked about finding probabilities. We talked about variables. Since we have things that kind of change over time or that depend on a situation or just a bunch of numbers in general, we can find the mean and standard deviation of our data, right? Now, the mean and standard deviation of a random variable is a little bit different than finding the mean and standard deviation of just a list of numbers or a chart or something like that, because we're dealing with the probabilities of those and we want to keep those in mind when we find or when we combine them together. Okay, but before we even go into an example, I want to show you a formula for the mean. I want to show you a different way to go about it than just the formula and some other terms that we use for this. Okay, so let's say we have a random variable, which just means it's a variable that involves probabilities. Okay, so like we can find the probability of everything in there. Okay, let me just give you some notation here. Sometimes instead of saying the mean of a random variable, I'm going to use that mean symbol that we talked a little bit about with the distributions. Okay, remember this was mu, right? And it represented the mean. And because we're talking about a random variable that usually uses the symbol x, I'm going to put x down here. So it's the mean of x. Okay. All right, I'm going to give you the formula, and I know it seems like a lot, but we'll go over what this actually means. It's this symbol, x times p of x. I know we have a lot of crazy symbols in here. Let's break this down and see what this actually is telling us. Okay, so I'm going to kind of zoom in here. I'm going to use a different color. Okay, looking at this symbol, or this formula, we have this weird symbol here, and it's actually an uppercase sigma, if you ever want to describe it. Does anyone know what this symbol means in math, Ariel? Yeah, it means the sum, okay? Whenever you see this funky little like E turn on its side symbol, this just means the sum, okay? Or like take the sum of. Okay, and it basically means everything after it that's in the brackets is what we're taking the sum of, okay? Now here we have x, which is our variable or all the different outcomes that can happen. And over here we have p of x, which is just the probability of x. Okay, so I know this formula looks kind of crazy and condensed, but all it's saying is take the sum of x times p of x for all of the outcomes that can happen. So in other words, it's really telling us to, well, multiply each of the x values and their probabilities to get x times p of x. And then once you're done doing all that, you're going to add up the numbers that you just got. Okay, so what I want you to do is either memorize the formula and know how to apply it, or memorize these 2 steps that might make it simpler to figure out how to find the mean. Okay. So one thing before we get into the rest of the notes is sometimes instead of saying the mean, I might say the expected value. And all that means is the mean. Okay, so if I ever say that, all I'm saying is the average. Okay. Let's go to example number 1. We have this computer monitor, and we know that computer monitors, when you look at the screen, it's actually not like a big picture. It's actually a bunch of these little tiny squares called pixels that combine together to make something that looks like a picture to our eyes. And these pixels are so small that it's not really uncommon for one to be like defective. So a lot of the times one pixel might not be working, but you can't really tell when you look at the screen. And what we're going to do is we're going to let X, or our variable, represent the number of pixels that are defective. Okay, so normally there's like 0 to 3 pixels that don't work on a screen. And we have the probabilities of each. Okay, so for example, the probability that you're going to look at your screen and there's 0 defective pixels, which means your screen is completely working fine, is 0.2. Okay. Now there's about a half chance that your pixel, there's going to be 1 pixel that's a defective, 0.2 chance that there's 2 defective pixels, and so on. Okay. Let's say I wanted to find the mean number of defective pixels here. The first thing I would do is look at my formula or look at step 1, which says to multiply each X value and their probabilities together. So I'm going to take my X value, 0, and multiply it by its probability, 0.2. 0 times 0.2 is 0. Next, I'm going to take my X variable 1 and multiply it by its probability. 1 times 0.5 is 0.5. I'm going to take 2 and multiply it by its probability to get 0.4, and 3 times its probability to get 0.3. So I'm just multiplying down the columns. Okay. What does step 2 tell me to do with these numbers? Yeah. Add them all up. Good. So I'm going to take my 0, my 0.5, my 0.4, and my 0.3, add them together, and I'm getting 1.2. This is my mean, and on average, I can say that the number of defective pixels is around 1.2. So maybe 1 or 2 defective pixels when I look at my screen. Any questions on example 1? All right, I know the formula looks weird, but the process isn't actually that bad. I'm going to give you a few moments to work on example number 2, and we'll come back in a little bit. Here, we have a mineral economist, which is a really cool job. I don't know what they would do, but I think it sounds pretty cool. They did a particular venture and they said, okay, this one thing has a probability of 0.4 for a 30 million loss, which is really crazy. And it sounds like you don't want to do it, okay? Then it says, okay, if I do this other thing, there's a probability of 0.5 for a 20 million profit. And then this other thing has a probability of 0.1 for a 40 million profit. So a very small chance of a really big win here. Okay, let's have X represent the profit. And we made a probability distribution below. I want to find the mean of this thing and see what would happen overall. Okay, I got Madison to write up her answer here. Do you want to take us through your steps? Mm-hmm. Perfect job. Multiply down, add together, and I just slipped on my own chair. Any questions on example number 2? All right, I think we're all experts on finding the mean of a random variable. Guess we have to go to a little bit harder and get the standard deviation. Okay, I know it's a little bit of a stretch from last time. Okay, finding the standard deviation of a random variable is a little bit different than finding the mean, mainly because we don't just have a group of numbers now, we have their numbers and their probabilities to take into account, okay? So I don't know if you remember from when we found standard deviation, but before we found the standard deviation of something, we actually first found the variance. Does everyone kind of recall that word? Okay. Does anyone know how to get the standard deviation from the variance? I think I heard square root, right? So I don't know. Okay, I know I'm getting kind of theoretical with you guys, but the standard deviation I did say before was this sigma value here. I don't know if you remember the Greek letter from the distributions era of our class, but we do have this circle with a line on top, or lowercase sigma, okay? And since we're talking about a random variable x, I'm going to put a little x at the bottom just to represent I'm working with the standard deviation of x, okay? Now, to get from the variance to the standard deviation, you have to take the square root. So the variance symbol is actually this one here. It's the same symbol, but with a square. Because from the variance to standard deviation, you take the square root. So to go up, we're actually going to square. Okay. Now, first, I'm going to go over how to find the variance. And then it's actually pretty easy to get the standard deviation because all you have to do is take the square root. Okay. I'm going to give you this very scary formula for the variance. It's going to look like a lot, but once we get through it, it actually doesn't seem too bad. And I also have a set of steps for you to memorize instead of the formula if it's getting a little bit too crazy. Okay. We're going to use that sigma notation again. Inside the brackets of our sum formula, we're going to have x squared times p of x. And then after we do the sigma, we're going to subtract off mu x squared. Now, I know this looks really crazy, okay? And once we get through this, I promise you it's not that bad. Let's just break apart this formula into its respective chunks and then figure out what they mean, okay? What does the sigma mean? Sum, good, sum, or add up, right? And it's telling us to add up everything in the brackets. Okay, so we're going to add up x squared. So we're going to square all our x values and multiply it by their probabilities. We're going to add them up. Once we're done adding up, we're going to subtract off this thing. What is mu x? What is this guy? Yeah, good. It's the mean, right? This is what we just learned how to find. Mu x is our mean. And we also have to square it, right? So subtract off the mean squared. Okay. So if you don't want the formula, which you don't have to memorize, but it is useful if you don't want to memorize like the steps, first you're going to find the mean, right? The mean is in the formula. You have to know what the mean is to find the standard deviation. Step 2, you're going to square all your x values because there's an x squared in here. Step 3, you're going to multiply your squared values by the probability of each of the x values. And if that sounds abstract, the example might give you a little bit more of an idea of what this means. Once we're done doing that, we're going to add everything from step 3 together. Once we get that sum, we're going to subtract off the mean squared. That gives us the variance. To get from the variance to standard deviation, we have to take the square root. Okay, so the same thing as we've done before. Let's do an example and see how this actually ties together because I feel like I spoke a lot. Let's do an example to kind of make this make more sense. Okay, so up here we have a probability distribution, 0 through 3. When I want to find the mean, what's the first thing I have to do? Multiply, right? Multiply down. 0 times 0.2 is 0. 1 times 0.5 is 0.5. 2 times 0.2 is 0.4. And 3 times 0.1 is 0.3. Okay. Once I get these values, what's my last step in finding the mean? Good, you add them up together. So if I add these together, I get 1.2. And that is my mean or mu x. So that was my first step. Okay. Let's do step number 2. Step 2 tells us to square each x value. So it looks like I need to take my x values and square them. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. A little bit of a theoretical question for you. Should I get anything negative in this column? No, why not? Okay, that's true. But what if there was a negative in the x value? Yeah, the square of any negative is actually positive, right? So all of anything in this middle row, no matter what the x values are, that was a smart answer, Brittany, but this column should be positive, okay? Okay, so anything in that column should be a positive number. Actually, anything on the second and third column of this chart should be a positive value, Okay. Moving on, we have to multiply our x squared values, which was the middle column, by the probabilities of x. Okay, so I'm going to take my answer from, and let me color code this real quick. I'm going to take my answer from the middle column. What am I going to multiply it by for 0? 0.2, which is the probability of 0. Okay, so I'm going to multiply this by 0.2, which I found up here. Okay, and well, that doesn't really help us too much because it gives us 0. Okay, then I'm going to take my answer from from the second column. I'm going to multiply that by what number? 0.5, good. And I got that one from the chart up top to get 0.5. And then the rest of the columns work the same way. I'm going to multiply 4 times probability of 2, which is 0.2, to get 0.8. And I'm going to take 9, my answer from the middle column, and multiply it by the probability of 3, which is 0.1. And that gives me 0.9. Any questions so far? All right. What's my next step? Add them all together. So 0 plus 0.5 plus 0.8 plus 0.9 gives me 2.2. Oh, I got something different, but I think it is 2.2. All right, moving on. Next, we want to find the variance. Taking a look at step number 5, it says I need to subtract my sum, which is 2.2, minus what value squared? 1.2, good, but I also need to square it. Okay, so I need to subtract off the mean, squared. I recommend doing the squaring in your calculator first and writing it down because I always mess up. This is 2.2 minus 1.44. Okay, and when I subtract them finally, I'm getting 0.76. So what I did just now is I found the variance. Okay, how do I go from the variance to the standard deviation? Square root, right? So the square root, oh, sorry, the standard deviation is the square root of the variance. And the variance is 0.76. So the square root of that is 0.872. And that is my standard deviation. Okay.
Is this going to be?
I'll put the mean on the quiz, but not the standard deviation since it's kind of fresh. All right. Any questions on example 3? All right. I know it's a lot of steps, but I think if you organize it in this way, it's actually not that bad. So I'm going to give you a few minutes to work on example 4. I have an optional example on the last page. If you have enough time, you can work on it. The answers are on the bottom, but we'll do example 4 and we'll do the quiz review. Then we'll be done. Let's come up to the front here. Here we have our probability distribution. Looks pretty good to me. First of all, we have to find the mean, right? That's kind of like our first step. Who asked to write this one? McKenna, do you want to go through how you got the mean? Perfect. And we got 0.7. Very good. Don't think we have any questions on the mean part. Then I asked you guys, okay, I wanted you to find the variance, which means you have to square everything and multiply the probabilities. Did I get Ashley to write this one up? All right, I promised her I wouldn't make her say every single one of these things, but since she wrote so much, I'll explain kind of what she did here. We took all the x values and we squared them, right, to get this column. Okay, remember everything in this column should be positive since when we square a negative, it turns into a positive number. Then Ashley was like, okay, I'm going to take my x values and multiply it by the probability of the number that we're looking at. Okay, so 1 times 0.3, 0 times 0.2, 1 times 0, and 4 times 0.5. Once we're done that, we had to find the sum, and I got, who did I get to write this one? Last one. Kate found the sum. Do you kind of want to go over how you got the variance and the standard deviation?
Yeah. I just like put some deviation to like sum and then and
Mhm.
subtracted grade. And I got 8.1.
Mhm.
I just took the square root of
Perfect job. Very nice as I've been walking around. Any questions on example number 4? Perfect. Now, of course, if you want to work on example 5, the answers are on the bottom. I'm not going to go over this example just because if you get the answer, you kind of know if you get it right or wrong. But I'd be happy to help you out with that anytime after class or anything like that. So I think it's about time for a quiz review, right?